All right, in this last example, I want to work on something where we're headed the other direction. So we have x as a function of y instead of y as a function of x. So first thing is we do want a graph of these. That can get a little bit tricky for people. But remember, if we can figure out what this looks like, so if we thought about it as y equals 1 minus x to the fourth, I do know something about that. X to the fourth has a roughly parabolic shape, and then I flipped it upside down and I shifted up 1, so it looks something like this. I also know that these intersections are at 1 and -1. You can get that just by inspection. If you plug in 1, you get 0. If you plug in -1, you get 0. Or you could get it by factoring. That's a difference of squares. So we could make this 1 minus y squared, 1 plus y squared, or x if we're looking at the bottom one. Okay, so this would be the shape if y was a function of x. Now we need to mentally flip that so that x is a function of y. So we need to switch our x and y. And remember, that means flipping over y equals x. So the y-intercept 0, 1 becomes an x-intercept at 1, 0. And then the x-intercepts at plus or minus 1 become y-intercepts at y equals plus or minus 1. So this is now sideways, roughly parabolic shape. The difference with the fourth power instead of the square is that it's a little bit more squared out at the end. Instead of just looping down the way a parabola does, it actually bulges out a little bit more. Okay, so this is the first one. The second one, if we think about, again, just switching those and making it y equals x cubed minus x, we can see that if we factor, that this crosses the x-axis at -1, 0, and 1. And then since it's a positive x cubed, we should start from -infinity and cross and head to positive infinity. And we could even figure out, if we're interested in roughly how far up and down that goes. Let me think about this. If we really want to get into it, we could say that y prime is equal to 3x squared minus 1. So if we set that equal to 0, we know that 3x squared equals 1, so x squared equals 1/3. So x is plus or minus the square root of 1/3, which is 1 over the square root of 3. Okay, so we probably don't need to get into quite this much detail, but I'm just wondering, does this little bump, oops, right here, the little maximum, in particular the maximum, does it go as high as the maximum of y equals 1 minus x to the fourth? I think that's going to be important when we're trying to decide where the area is trapped between. So what I really wanted to know is if I plug that back in, so I know the maximum is going to happen at, because I know what my picture looks like, x equals -1 over the square root of 3. And if I plug that back in, y equals, we're going to get that whole thing cubed. So -1 over the square root of 3 cubed. And then minus 1, oh, negative, so plus 1 over the square root of 3. Okay, so let me think about what I want to do with that. If I multiply this by square root of 3 squared, actually, so if I multiply this top and bottom by 3, then I get 2 over 3 root 3. Let me see, just in case that doesn't make sense. What I'm saying is that you could think about this, you can do this in either order. So we could say that's the square root of 27, and then we could split that up and say that's 9 times 3 underneath, which we can extract the root and say that's 3 root 3. So what we really have is 2 over 3 root 3, which is definitely positive, so that's a good sign, and it's definitely less than 1. If we just look at the 2/3, that's less than 1, and then we're actually making the bottom a little bigger by multiplying by root 3, so that's making the fraction even a little smaller. So less than 1 was what was really important to me, I think, to see that it wasn't going to jump up higher than the maximum of the other graph. So I think what I'm getting is that this guy, when we flip it on its side, let me think about that, it's going to go flipped on its side. So this point, so we're going to cross at -1, 0, and 1 now on the y-axis. And over here where x and y both go to -infinity, will become down here at the bottom where x and y both go to -infinity. So I think we're getting something like this. And then it's going to cross and switch, and we're going to go x goes to positive infinity and y goes to positive infinity. Okay, so kind of a weird one. I would sort of forgive you for using some technology, but I would expect you could get this rough shape. What I would forgive you for maybe using some technology for is just to check that this really fits in underneath as opposed to crossing up and going higher, which I believe it does, but I would be okay if you had to do a little checking to make sure of that. Okay, so here's the deal. This is one of those where it's a little weird if I try and slice vertically, because at some points I'll be crossing from one curve back to itself. So this is a really good candidate for instead slicing horizontally. And notice that then, no matter where I'm at, when I slice horizontally, my rectangle always stretches from one of these curves to the other one. It's always stretched between the two. And then it's important to recognize which is which. So this is the x equals 1 minus y to the 4th. And this one is the x equals y cubed minus y. So when we do this, you just want to remember that the bigger x is going to be to the right. So we're always going to take this right-hand one minus this left-hand one. So we're going to integrate 1 minus y to the 4th minus y cubed minus y dy. Remember, the dy is the width of your rectangle. In this case, I guess you could call it height since we're going opposite direction. That's my delta y. And then the width is the 1 minus y to the 4th minus y cubed minus y. And we need to know where to start and where to stop, but I think we've already kind of established that. They cross at -1. Let me get this in the right order. 0, -1, and 0, 1. So we're going to go, remember this is a dy, so these are y values. We're going to go from -1 to 1 on the y-axis. Okay, so as we crunch through -1 to 1, we are really working on a 1 minus y to the 4th minus y cubed plus y, which is not such a terrible thing to have to integrate, and we have nice limits of integration. So it's a little weird on the trying to graph and make sure you're visualizing correctly, but I hope that from there it doesn't give you too much trouble. The antiderivative of 1 is y. The antiderivative of y to the 4th is 1/5 y to the 5th. For y cubed, it'll be 1/4 y to the 4, and for y squared, or for y, it'll be 1/2 y squared. And then we're going to go from -1 to 1. Okay, so when we plug in 1, we're going to get 1 minus 1/5 minus 1/4 plus 1/2. When we plug in -1, we're going to get -1. Y to the 5th, -1 to the 5th is going to be still negative, so that's going to become a plus 1/5. The y cubed, -1 cubed is still going to be negative, so that's going to be a plus 1/4. -1 squared actually ends up being positive 1, so plus 1/2. Okay, so let's see, what actually is going to go away? The ones are not going to go away. I'm going to have a 1 plus 1. The 1/5 are not going to go away. I'm going to have -1/5 minus 1/5. The 1/4 are not going to go away. I'm going to have a -1/4 minus 1/4. The 1/2s will go away. I'll have a 1/2 minus 1/2. So what am I looking at? I'm looking at 2 minus 2/5 minus 1/2. So let's see, the 2 minus 1/2 is a 3/2 minus 2/5. Okay, I'm not going to be able to get away with avoiding the common denominator. So I get 15 tenths minus 4. So 15 minus 4 is 11 tenths. So that area trapped between that I shaded is equal to, I guess I didn't shade, there it is. That area is equal to 11/10. I don't think I ask you, I know I don't ask you to do perimeter on these sideways ones. At least I'm pretty sure now that I said I know. I'm worried that I lied. So I'm not going to do it here. If it does crop up and give you trouble, just let me know. But I think that we're avoiding that in this section. Thanks for watching.